You ever see these giant tech companies pushing out new features like every single day and wonder how on earth do they do that without everything just collapsing? Well, it's not magic, it's automation. And today, we're going to pull back the curtain on the CI/CD pipeline. This is the engine that really powers modern software development.
So first, let's talk about why we even need all this. I mean, traditionally, getting code from a developer's laptop to, actual users, it was a total nightmare. We're talking a slow, manual, painstaking process. Lots of late nights, endless checklists, and, of course, the classic excuse, well, it worked on my machine.
And this really shows you the before and after picture. On one hand, you've got that old manual way. It's just a mess. It's slow, it's full of human error, and things are different every time. The solution is what we call CI/CD. That stands for continuous integration and continuous deployment. And that, my friends, is a straight path to shipping software that's fast, reliable, and consistent every single time.
Okay, so how do we actually pull this off? Well, you need a team of highly specialized tools. So let's meet the three superstars that are going to form the backbone of our entire pipeline.
First up, you've got Docker. The easiest way to think about Docker is like this. It creates the perfect shipping container, but for your code. It takes your application and everything it needs to run, all the libraries, the settings, the whole shebang, and bundles it into this neat little package called a container. And here's the magic part. That container runs the exact same way everywhere. On your laptop, on a server, in the cloud, it doesn't matter. Consistency is everything.
Next up is Jenkins. Now, if Docker is building the shipping container, Jenkins is the automated factory foreman who's running the whole assembly line. It just sits there watching your code, and the second a developer makes a change, Jenkins just springs into action. It grabs the new code, tells Docker to build a new container, it runs all the tests, and gets everything ready to go, all without a single person having to lift a finger.
And finally, rounding out our team is Kubernetes. Think of this as the global logistics manager, or maybe the fleet admiral for all of those Docker containers. Because you're not just running one container, right? You might have hundreds, or even thousands. Kubernetes is the one that orchestrates this entire fleet, making sure they're all running smoothly, automatically replacing any that fail, and even scaling them up or down depending on how much traffic you're getting. It's all about managing complexity at a massive scale.
All right, so let's see how this all-star team actually works together. It all starts with getting our application ready to be packed into one of those universal shipping containers.
And we do that with a simple little text file called a Docker file. It's basically just a recipe for our container. And look how simple it is. It's really just three basic steps. From says, hey, start with this environment. Copy says, okay, now add all of my code into it. And CMD tells it what command to run to actually start the app. That's it. This is the simple, repeatable blueprint for our entire application.
So, with that blueprint ready to go, it's time for our factory foreman, Jenkins, to step in and take over. This is where the continuous integration magic really starts to happen.
And here's exactly how that works. First, a developer pushes their new code to a place like GitHub. Jenkins immediately sees that change, and as you can see in step 2, it automatically builds a brand new Docker image from our Docker file. And finally, step 3, Jenkins pushes that new, ready-to-go image to a storage place like Docker Hub. The key thing here is that the entire process, from code on a laptop to a deployable image, is totally hands-off. Okay, so our new container is built, it's tested, it's stored. Now for the fun part. It's time to hand it over to our fleet admiral Kubernetes to actually launch it so the whole world can see it. Now we give Kubernetes its instructions using these simple configuration files. The deployment YAML file tells Kubernetes what to run. So in this case, it's our app's image, and we're telling it we want 3 copies running at all times for reliability. Then the service YAML file tells Kubernetes how the outside world can access it, opening it up to users on the internet. It's really that straightforward. One file for the what, one for the how. So we've walked through the how, we've seen the tools, the files, the whole flow. But the real game changer here is the why. This isn't just some cool tech upgrade. It's a completely different way for teams to build software. This is the very heart of the DevOps culture, where those old walls between developers and operations just come crumbling down. And this chart just nails that payoff. I mean, look at speed. That's not just about moving faster. It's about getting your new ideas into your users' hands before your competition does. Reliability means way fewer late-night emergencies and building trust, because this automated process catches bugs before they ever see the light of day. And consistency is huge. It finally solves that old "it worked on my machine" problem for good. Now let's be real for a second. The road to perfect automation is not always a perfectly straight line. You are definitely going to hit some bumps. A tiny typo in a Docker file, some permission error in Jenkins, a formatting mistake in a Kubernetes YAML file. These things will happen, and they can stop the whole pipeline. But listen, these aren't failures, they're feedback. Each one is just a little lesson that makes your whole process stronger. They're just the normal, expected part of the journey.
And you know, this quote from the source material really just sums it all up perfectly. This stuff isn't some new fad or a fancy trend. It is the industry standard. Getting a handle on this automated workflow is an absolutely crucial skill for anyone in software today, because this is how modern, reliable apps get built.
So when you have this kind of power, the power to go from a single line of code to a globally deployed application with just one click, it fundamentally changes how you think about creating things. It opens up so many possibilities. So the only question left is, what are you going to build next?